Okay, welcome everyone. We are gonna start the third lesson now. I've also started the recording. And this is what we're gonna go through today. All this stuff. Basically, this is just the foundational things of Godot. And these are pretty much also Godot specific, but transferable to other engines as well. I don't think I'll be using Paint or my drawing pad all that much today, because this is basically just like showing things around, but I'm gonna get this to a notepad to have it around, even when we have a Godot open. So, foundational blocks of games and simple player motion. Last week we looked through all the basics of programming and also some Godot built-in functions. So now we are gonna use those. Okay, so actually I'm gonna set my drawing pad up because I have something to sketch. I just gotta position my keyboard. Okay, I'm not muted. Good. All right, so I could just put these here as well, like we did the last time. Okay. So we're gonna start with the first line and just go on one by one. So in Godot, you could have seen this before, and we actually talked about this before, but if you're seeing this lesson and not the previous ones, we basically have node 2Ds and controls that make up a game. And both of these extend from the node class. They inherit the node. You can also say this if you want to create a child node, for example. You can see node is at the top of every single node, and here we have node 2D and control. And you can just read the descriptions. Node 2D is a 2D game object, right? And control is for GUI controls. So one interesting topic is the layering of these. Like, what is layering? Layering is basically the drawing order of nodes. And if you're familiar with game development, you know that the UI is always on top. So like there is no node to the object, and that would be above the UI. We can just see this for ourselves. I'm going to create a new scene. It could be a 2D scene. I'm going to call it layering. Oops. Okay. And I'm going to add a node, a sprite. You know, that's for textures. And also a label, which is a control node. So if I just type here, and yeah, you can see Godot actually rewired this in Godot 4, but and also because we are under a node 2D scene here, but in like the real or in a actual game, you will see that there's the user interface. Like even if I just open Minecraft, right? Minecraft, if I type it in, you will see what's part of the UI. I'm just gonna type gameplay, I don't know. Yeah. So the UI is this little bar here, because technically you can change the way they are ordered and drawn, but it just makes no sense oftentimes. So yeah, the practice is that the UI is on top, the user interface or heads-up display, however you want to call it, and Node 2D or the world is beneath that, right? We have this interesting thing called Z indexing, and you know, coordinates and how they go, like x y z with the axis designations, and that gives you an idea on what z index may mean. It is the so it defines how how on the top a particular node is. So by default, in Godot, the drawing order and the layering order is defined by these sibling indices, and that means that layering is the parent of these two nodes here. So they are siblings, the sprite 2D and the label, right? And in Godot, it's always so that the first child is drawn first, and then the next one goes above it, and so on. If I make a copy of this and put it here, see, this is how they are drawn in this order, and they just overlap each other. You could say that. However, with Z indexing, if you find this property here under ordering, if you increase this, you can see that the label is now above all these other sprites, no matter what you do. Like, you can make a million copies, right? It will still be above them, because the Z index specifies the drawing order. If you hover over this property, you can also see that it says it controls the order in which the nodes render. The node with a higher Z index will display in front of others. And in Godot 3, you only had Z index as a variable on node 2Ds, but fortunately they introduced this on control nodes in Godot 4, which makes many things more convenient. They also have Z as relative, and this is just pretty self-explanatory. You can just read this little paragraph here. Because Z index is also inherited from the parent. So if the Z index of this is 0 and we have this Z as relative turned on, then the total Z index of this label is 1. But if I increase this, then every node's Z index value technically grows by 1. So the label now has the summarized Z index is 2, and the sprites have 1, 1. So you could say that it adds up down the hierarchy. If this sprite had another child, and this had the Z index of 5, then this child would have the Z index of 6 already. It just goes down as the hierarchy goes on. And so I think this is a good time to merge into the next topic, which is inherited and relative values, right? Because Z index is also inherited, as we just discussed. And so are transform properties, because as I'm moving this sprite here, you can see that this child is also moving with it, because it's just it's its children, it's its child, sorry. So it inherits its position. However, there is still a fixed offset between the two, which you can see here in as the position variable. If I set this to 0, 0, it goes back to where the parent is. And this position also just gets inherited as long as there's a higher root node, because if I move everything here, or if I move the scene root, you can see everything moves. An interesting property is the modulate, which basically defines the color of an object. But you can see this has a self version, so self modulate, and what it does is that basically keeps the color to itself. So let's start setting this variable. If I set it to like this color, this bluish purplish color, you can see that the child also got that. It inherited it, you could say. But if I set this one, only the parent is affected, right? And then one other thing about position is that scaling is also inherited, just like this thingy, which kind of tilts the way the node is displayed, and also rotation. And yeah, scale too, of course. So an interesting question is how we know the absolute position of something, because okay, if we look here, the position of this is 180 on the x and 99 on the y, but what if I need to know the absolute position, because I want to see how many like steps it takes to get somewhere else, right? And well, of course, you could just say you add up all the parents' positions until there is no parent, but but that would be a bit tedious to do every time. We just want to know the position, or the absolute position, or global position. You could say global, because that extends to the entire game scene and not just relatively to the direct parent. So if I create a script here, I'm gonna call it custom sprite. We have this thing called, we have the print function, we looked at the previous lesson. We have this thing called global position. And then you can just see there's a lot of other global stuff. Here's global scale, rotation, whatever. So we have global position, and if I launch the scene, you will see it prints something completely different from what we have here. And basically just added up the position of this sprite and this sprite. And you may say it is just simple to reproduce that, but consider a scenario where you have like 50 parent nodes till you get to the level root, right? If you also print position, as we see in the editor, you will see it just shows us what we see here. And just to show you, now these are, whoops, wrong scene. These are the same now. And I may have not highlighted this, but if you want to launch or if you want to run the game in the scene you are currently at, you can press F6 or click this button. So this launches this one. Otherwise, if you click this button or press F5, it will launch the scene you assigned in the project settings under application slash, oh wait, is it? Yeah, under application slash run as the main scene, which is this one, is the scene we've tackled with previously. So yeah, we got this. That's not a tick. That's a tick. For layers, there's also something really cool called canvas layer, a node used for independent rendering of objects within a 2D scene. Basically, this is also something about layering, because you can see it as a layer variable, and this is kind of the same as the indexing. Lower values are drawn behind higher values. So this is just used for UIs most of the time. And I also, when I just create a GUI class or something like that, I tend to use this canvas layer as well. But yeah, we'll get into that in detail in a bit. So okay. Oh yeah. Okay, now we have well, since I just created a script on this sprite, right? Let's say I want to move it. Okay, so we looked at it in the previous lesson, I think. Oh yeah. Yeah, we didn't actually move an object, but now we will. So we know the position variable exists, and technically to move anything, we just need to modify that. So let's try moving it to the right. Fortunately, Godot has this constant defined for us, this vector to the right. And yeah, we can just do it like this. Or we could do position.x plus equals 1 or whatever. I could have done right.x, right? But it's an overcomplication. So let's launch this. Now we are moving. However, we talked about this at some point. I think it was the first, no, it was the lesson before, right? That this function is called every frame, and data is the elapsed time since the previous frame, which means this doesn't run at a fixed frame rate. So if I run this on a lower end computer, this is going to run less times than on the PC I'm using right now. And that is a serious disadvantage, because just imagine a competitive game where someone uses this function to move the player, right? And someone on a worse PC moves like, I don't know, one fourth the speed I do on my PC. So a good practice is multiplying this by delta, because it's the elapsed time since the previous frame. So you can imagine, just to help you understand this, if it runs at 10 FPS and the process function says we move 1 unit multiplied by 0.1, because this is the delta, right? That means, yeah, that means we move 1 unit per second. And then if we play the game at 50 FPS, then we move 1 multiplied by 0.02 every frame, right? But since we run at 50 frames per second now, this is also 1 unit per second. And then now if I run it, you will see it is much slower because we are basically dividing this by 60 or something around that. So of course we can just speed this up a bit, right? Now we're a bit faster. I'm gonna see if I can log the FPS somehow. Oh yeah, I think I can. Let's see. Okay, I'm going to remove this and show you the difference. I'm gonna make it something ridiculously low, like 5 FPS. Does this take effect? I think so. Okay. So now we're running at 5 FPS. This is a simulation, you could say. But now if I remove the FPS limit, or even if I set it to 60, you can see just how faster I am. But if I do delta, let's run this at 5 FPS again. Okay, we are moving at that pace. And now it's the same, right? It is about the same. It's not as smooth because we are moving in a kind of bigger chunks, but it's just much better. And it is unified, right? On all devices. So that's how you handle smoothness and the FPS issue. We also have this global class called time, which can do a bunch of interesting things. It can, for example, you can change the time scale. I'm not sure what that variable is called here. Or maybe it's an engine. Yeah, it's probably an engine. Or OS. OS is for operating system. Yeah, time scale. So this basically, this is pretty easy to like remember because time scale just, well, how do I put this? It specifies how quickly time passes. So if I set this, or if I multiply this by 2 or 20, see, now I'm moving much faster. And if I divide it by like 10, see, I'm super slow. So this is good for cool effects that you can create. And yeah, the time class is useful for getting the elapsed yeah, the elapsed time basically. We also have this get ticks function, which I usually use. It is the amount of time passed in milliseconds since the engine started. So yeah, this is useful if you wanna like tie something to a cooldown, because let's say we want to move every we want to jump by like a lot every half second, okay? So we will need to create a variable to track the let's jump timestamp. We can keep it 0 right now, and then we'll create an if. So if the current time minus our cooldown, which is 500 milliseconds, half a second, is bigger than the last jump timestamp, then we jump ahead, and we also need to reassign this variable to the current timestamp, otherwise we will jump forever. You can see how we are moving right now. And yeah, that's it for this time class thingy. The next thing we want to do is some input management and just tackling with vectors. What you're seeing here is linear motion. We will get into non-linear motion as well in a later lesson, but for now we are sticking to this because this is simple. Okay, so inputs. In the project settings, you will see a tab called input map, which basically lets you define inputs. We also have built-ins here. These are mostly UI things. But that doesn't mean they cannot be used for in-game action, actually. But okay, let's add our moveset. So we type the name here. Let's move right. We can add the event here, listening for input. It's saying that, so if I just press anything, if I press D, it is giving me this physical key. So yeah, we have some things. Oops, we have some things to disclose here. You can see it's saying D or D physical or D Unicode, and then additional options, blah blah blah, and physical key code position on US keyboard. So this is interesting because keybinds can be based on their physical position or their Unicode values. So one interesting example I came across a few weeks ago was that the French keyboard, if you type it in, I think it's the it's the French keyboard that doesn't have a W and A on the keys that EU and US keyboards do. So if you don't tie player motion to these physical key positions, that will mean that the French have to use this key here, and these two to simple up, down, left, right movement. Makes sense? So this is one of the cases where we usually use the physical position, because this is just physically convenient, right? If you wanted to tie the inventory key to E or I, sorry, and you know, or yeah, if you wanted to tie something to Y on the US keyboard, that's also a bit problematic because EU keyboards usually have Y wherever the US keyboard has Z. I think it's here or something, or oh yeah, it is here. Sorry. So that's the same. That's the same thing with this WASD layout thing, but it's not that severe after all. And then again, most games tie these to physical position when the actual physical layout matters. So okay, let's create these. The rest of our functions. Physical, move up, and move down, which is S. Okay. So now we can do two things. We have this input class, right? Or input function, sorry. And we also have process, so we could do the input checks in either, but I prefer doing it in input because input fires only when an input is made, but process does every frame. So this is a bit of a performance consideration. And so to check for a input press, we use the global input class, and we type input dot is action, and now we have three options: just pressed, just released, and pressed. So what's the difference, right? Think about it. Just pressed is when we start pressing. So I'm going to hold A, okay? Now I just pressed it. Now I'm pressing it. Now I've just released it. Okay? So that's a good way to kind of visualize it. So we are just gonna do this, and we can do this. But wait, hang on. So we don't have data now. We don't know how much time elapsed since the last frame, right? So that's one of the advantages of doing this in process, but I think we can retrieve the elapsed time since the last frame somehow else, and if we cannot, that is okay. Okay, apparently they don't have a variable for that, but worry not, because we can just introduce one, right? Let me just call this underscore data, and we can just do this, you know, we just create a variable here and assign it to whatever we retrieve from process so that we can use it in input. Now if I do this and remove these, guys, I'm pressing D and nothing's happening. But if I keep repressing it, now it moves, because we are using just pressed. So if you use pressed, there we go. That's better. And then now if I do the same thing in process, I can also use local data here. Wait, we're gonna move twice. Not good. Yeah, there we go. Now we move out of the screen. Probably for a motion like this, it is a better practice to use process, because input sometimes stuttered. You could see that. So I'm gonna hold D continuously. See, it feels a bit laggy. And yeah, it just feels laggy, and I also don't think it it transmits after every frame of the same input. So using process for motion is generally better, and then if you have just occasional stuff like is the player opening the inventory, then storing or like handling those in the input function is better. Okay, so let's do the same thing for left. Oops. Ah, my keyboard is just so away from me. Okay. Now we can move both left and right. And we still have that. Okay. And then now we will need to create the rest of these branches for up and down. Or we can use something else for the axis. I think Godot should have built-in axes for this. Oh, okay, never mind. So this is really cool. We have this get axis function, which takes two input events, and you can see one of them is the negative action and the other is the positive. So if we feed this move left and move right, we can just add that to the X position right away. We could call this 200 hour speed. And see, it works. And then we can do the same thing on the y-axis, but be careful because in Godot, moving up is the negative value, because the coordinates you can see it on the arrows right here that y goes positive downwards. You can even see how I'm dragging the object and the y value of the position just increases. Okay, cool. There we go. Now we're moving. And yeah, that's input management for us. At least the basics. You can also attach joypad buttons and axes. You can see all of them here, all the buttons as well, but I think this also listens for input if I press anything on my joystick. Yeah. So yeah, Godot fortunately supports controllers. Okay. Let's make this code a bit fancier. and do this, create a variable called axis motion, which is going to be a vector 2, and we'll just have these values. And now we can add it to position altogether and do the multiplication, because if you multiply a vector by a single number, the multiplication will take effect on both axes. And now if I print the axis motion, you can see it's always a value between 1 and 0 or -1 and 0. Because basically, so if you imagine the numbers, right, here's -1, here's 0, and here's 1. If you take the horizontal axis, then this part is the move left, and this is the move right. So if I were to use a controller, there will be some sensitivity there to it, because you know a analog stick, for example, has quite the sensitivity. You can just drag it. You can drag it a bit or like entirely, and that's a different value. But key presses are basically just zeros or ones, right? I can actually try adding these. So you can see I will just add the joypad axes. Okay, and if I restart, yeah, see? You can see I'm barely touching the analog stick now. And it's not the exact one value. Alright. Okay, so the next and the last thing to talk about is cameras. In Godot, a camera is called camera 2D, and you can see we're actually not using any cameras right now. There's no node to redo that, so by default then our default viewport, as we call it, is this blue rectangle you can see here. You can't quite make out the blue here because it collides with the red and yellow lines, but here you can see the two other sides of the rectangle, and that's the area we are seeing by default. So if I create camera 2D, now we have a new rectangle, and that is what we are seeing now. If I disable that, we get back to the default viewport. So how do we tie this to the player? You can think about it. It is actually pretty simple. We have talked about the inheritance of positions previously, and we are going to use this logic right now. So I'm gonna attach the camera under the sprite, but however, you can see now that we have an offset from this, because the camera was spawned at the origin of the root, right? And now when I reassign this as a child of this sprite, it maintained its position. So it is ideal we reset it to 0. And now we have the camera following us. However, you may have noticed that in some games, the camera isn't like directly in you like this. It kind of just takes some time to catch up. So we have this tab called position smoothing. And if we enable this, much better. Much better. You can see that the camera is not entirely in the middle now. And we can specify speed here, so if I say 1 pixel per second, this is gonna trail behind us by a lot. If I say 3, that's a bit better, but it still feels a bit slow, right? So maybe 5 is the best value. And we can specify some offset whatsoever. We also have boundary limits for like, level boundaries to like not show the camera out of bounds. This is something we can do with collisions, and we may actually do this when we get into the collisions lesson, which is like a bit far from here. I think it's the 6th lesson. Yeah. But we'll get there. We'll definitely get there. And I think we have gone through everything we really wanted to. So we have the camera node, we have input management, vectors, and the FPS whatsoever. So yeah, I think that is it. One other thing I want to show real quick is this is pretty important, especially when you're working within a team or if your code is just all over the place. So I think I haven't shown this, have I? Yeah, I have not. Okay, so Godot has this thing called at export. You can actually see if you click on it. This is in the global scope. In the yeah, built-in GDScript constants, functions, and annotations. My mic is gonna tilt. Uh-oh. So yeah, this is called an annotation. I was looking for its name. And basically what this does is that you can see now in the inspector, we have this speed variable, and if I want to make it really high, see I'm moving really quick now compared to when it was 200. And there you can set the default value here and all that interesting stuff, but this is pretty useful, this at export. Especially when you are working with like designers or just really non-coders who want to modify or like tackle with some settings. I use export all the time as well, even for my own projects, because it is just easier, you know. It is much easier to also customize things, because if I wanted to have two characters with different speeds, I could not do that with a single variable, right? Like from the editor. But thanks to this export, I can specify the speed on these two instances, because if I adjust it here, it will still be the same right here. And there you can actually see I'm moving both of them now, and this one's moving at half speed approximately. So yeah, I think that's it for today, guys. If you have any questions, oh, thank you for this resource. Yeah, this. Oh wait, I've actually just seen this the other day. I didn't watch it entirely, but I remember having this in my recommended. Yeah, and I just scrolled through it. This is pretty good. And some other cool thing is just setting the camera boundaries dynamically and like adjusting it to the level layout. And again, we will get into that when we deal with collisions. So yeah, I think that is it for today.